so here we go. So now we're going to talk about how to write a function rule, okay? Now we've done this already. I've given you many clues. We've talked about power words. We've talked about how to read the sentence and pull out the important parts. So here, this is about insects. You can estimate the temperature by counting the number of chirps of the snowy tree cricket. All right, guys, I don't know. The outdoor temperature is about 40 degrees Fahrenheit, more than 1/4 the number of chirps the cricket makes in 1 minute. What is the function rule that represents this situation? So now you got to read all this and you got to figure out, okay, what am I going to take out? What is this telling me? So let's see what it's telling you. It's telling you the temperature, right? The temperature is 40 degrees Fahrenheit, more than 1/4 the number of chirps in 1 minute. So here's what we're going to get out of it. Now, how are we going to relate this? How are we going to make a function out of this? The first thing we're going to do is we're going to set variables, right? Let T be the temperature, and let N be the number of chirps in a minute, okay, per minute. Because that's what it's saying. In 1 minute, that's the same thing as per minute. Let T equal the temperature, N equal the number of chirps in 1 minute. Now, we're going to read this. For here, for temperature, we're going to put T, okay? T is, the word is, whenever you see is, means equals. We're going to leave the 40, right, just the number. More than, what does this mean, more than? We're going to add 1/4, we're going to leave as 1/4 of, this is a good one, times 1/4 the number of chirps in 1 minute. So this is times, and we said N for the number of chirps in 1 minute. So first we kind of wrote it out, then we deciphered temperature, we said was going to be T. The word is means equals, 40 is just a number, more than is plus, 1/4 is just a number, of is multiplication, the number of chirps in 1 minute, okay, of. So now, here is our function rule. T equals 40 plus 1/4 N. There you go. Now, all of this looks hard, but look, it's really not that hard. Let's look at the next one. Okay, a concert seating plan is shown below. Reserve seating, this is very important here. Reserve seating is sold out. Okay, so I have reserved seating here is sold out. So that means that all the seats sold, right? Okay, the total revenue from ticket sales will depend on, will depend on the number of general seating tickets sold. Okay, so doesn't this sound like Y depends on X, right? And Y is our output, X is our input, Y is our dependent, and X is our independent. You remember all that good stuff? That's what it's saying right here. Will depend on. So what's on the left? Total revenue. So total revenue is now all of this good stuff. Will depend on the number of general seating tickets sold. So now that goes over here, number of tickets, if you can read this, sold is now my X value, my independent, and my dependent. Okay, so now it's asking us, write a function rule to represent this situation, this whole situation. So the first thing we need to take care of is we need to figure out how much money is over here that's sold out, right? There's 12 seats per row, right? 12 seats per row, and then there's 10 rows. So we're going to multiply these two together, right? 10 times 12, and that's 120 seats. So there's 120 seats right here, and they're going for $25 each. So 120 times $25 each, right? Do my little multiplication sign there. I'm going to do long multiplication. 5 times 0 is 0. 5 times 2 is 10. 5 times 1 is 5 plus 1 is 6. 2 times 0 is 0. 2 times 2 is 4. 2 times 1 is 2. So when I add that up, that's 0, 0, 10, that's $3,000. Okay, so you guys check me with your calculators. So, all of this is already $3,000. Okay? Now, we still have to figure out what's going on up here. Right? We still have to figure out what's going on here. So now up here, we have 30 rows, and there's 16 seats. So we're going to do the same thing. We're going to multiply 16 times 30, right? 0 times all this is 0. 3 times 6 is 18. 3 times 1 is 3, plus 1 is 4, right? So there's 480 seats altogether. Okay? Whew, okay. So now let's reread this again. The total revenue, that's my total revenue, right, from ticket sales depends on, right, the number of general ticket sales sold. Okay, the number of ticket sales sold. Well, we have 480 seats, right? And they're $10 each. You see this? They're $10 each. So, but we don't know how many is sold here. We have no idea what's going on here. We just know that these were sold out. So, can I say my total revenue is equal to 10, right? Okay, so total revenue depends on is equal to $10 per seat, right? Per seat. If you want to use S, we can do a little S there, per seat, plus $3,000, right? So let me erase all this over here in my way. All right. Plus $3,000 of the tickets that's already sold, okay? So, it's $10 per seat because we don't know. We know there's 480 seats, we just don't know how many seats are going to sell. So it says write a function rule, we just did that. We did the total revenue equals $10 times each seat plus the 3,000 that are sold out. What is the maximum possible total revenue? Well, all you do here is you stick in, you know there's 480 seats, you plug it in right there. That's going to give you your total possible revenue. That's going to give you if everything is sold out. So 480 times 10 is 4,800 plus 3,000, right? It's going to give me my total possible revenue, which is 7,800. So I can make $7,800 if all of my revenue is sold out. That's the highest revenue that I can make. All right. A landfill has 50,000 tons of waste in it. Each month, it accumulates an average of 420 more tons of waste. What equation is a function rule that represents the total amount of waste after m months? All right, so let's look at all of these. I want you guys to take a look at them, and then I want you to tell me what the answer would be, and then we'll go over it. All right, let's go over this. Okay. So, we're talking about waste, right? We're talking about the total amount of waste. Total amount of waste. So I know that W is going to equal something, my total amount of waste. All right, so we got a W, a W, a W, and a W. All right. So a landfill has 50,000 tons of waste in it. So right off the bat, I have, let me write it over here. Right off the bat, I have 50,000 tons of waste. Boom, right? Each month, there's a power word, each month, right? So there's that M for month. I'm going to have an M right here, right? It accumulates an average of 420 more tons. So 420 more tons added to the 50,000, okay? So let's look. 420 plus 50,000 a month, no. Minus, no. Minus, no. So here it is. 50,000 plus 420 a month, which is exactly what I did. Last one. A kennel charges $15 per day to board dogs. Upon arrival, each dog must have a flea bath that costs $12. Okay. write a linear function rule for the total cost n. So n is my total cost. Okay? And then I have an each day charge there, right? So let's put X will be my per day charge. Okay? X is my days. My days. Let's just put X as my days. Okay? So now, right when you walk in, my total cost is going to depend on how many days, right? 15, how many days, and we said X. Plus, right off the bat, I got to take out $12 from my pocket, right? Boom. So it's $15 a day plus $12. And then how much does a $10 stay cost? So now we're combining, right? We wrote a function rule. Now we're going to evaluate it for 10 days. So what you're going to do, you're going to take the 10 and you're going to plug it in and evaluate. So 15 times 10 plus 12. And you guys write that answer. And that will be it. Good luck tomorrow for practice.